Welcome to the MS SQL Tips webcast, Deploying SQL in the Cloud, 5 Things You Need to Know, sponsored by SIOS Technology. I'm Greg Robidoux, co-founder of MS SQL Tips and today's webcast host. Joining me today is Tony Tomarchio, who is the Director of Field Engineering for SIOS, and Rodney Landrum, who is a Microsoft MVP, Professional Services Consultant, and Entirety, a division of hosting. They can both tell you a bit more about themselves shortly. Before we get started, if you have questions, you can submit them any time during the webcast. Answer your questions in the question area in your presentation controls. We'll try to answer as many questions as possible during today's webcast. If you have any technical issues with the sound or screen quality during the webcast, also use the question area to let us know. If you're not already a member of the MS SQL Tips community, we invite you to join. You can go to www.mssqltips.com, sign up for our newsletter, read any of our tips, download white papers, watch videos, and post your SQL Server questions to be answered by our community members. This webcast will be recorded and archived for future playback, and you'll receive a follow-up email with links after today's event. So at this time, I'm going to turn things over to Rodney and Tony, and they can begin.
Okay, hi, my name is Rodney Landrum. As Greg said, I am a DBA/BI consultant working for Entirety, a division of hosting. I have been doing SQL Server related work for longer than I really want to account for. The topic today obviously is going to be on the 5 things you know to deploy SQL in the cloud. And I'm going to turn it over to Tony to introduce himself.
Great, thanks Rodney. So hi everyone, my name is Tony Tomarchio. I'm with the field engineering team here at SIOS. I've been with the company for about 5 years. Prior to that, I spent time at Sun Microsystems and Oracle and various other startups here. So I've been in the systems management and high availability space for well over a decade. And after Rodney goes through his content here, I'm going to be telling you about a way to achieve HA in the cloud with SQL Server.
Okay, thanks Tony. And let's get started. Okay, so the 5 tips that we're talking about today, just want to take a brief bit of time, talk about some of my experience with the cloud. Some of my recent experience, I was actually in my boss's office one day, and after I think he had either seen a webinar or was reading some Gartner reports, it was pretty obvious to him that everyone's moving to the cloud. And this is several years ago. So he came to me and said, I think we should move to the cloud. What do you think, right? So I was a DBA at the time. And, I had heard of the cloud. I had obviously done some work with the cloud, but nothing to the extent of actually talking about moving a production instance or a very large infrastructure to the cloud. So his idea was he just wanted to move to the cloud, really for the sake of moving to the cloud, right? So that may not be the best idea for all businesses out there. But the flip side of that, there are companies who really need to take advantage of the cloud for various reasons. My former boss, for example, we had a server room that was comprised of about 4 terminal servers and 2 fairly large SQL servers, and we were right in the middle of Hurricane Alley. And our small little on-premises data center with 2 racks really needed to take advantage of getting out of that area and moving to the cloud. So within the course of about 2 months prior to hurricane season, we bit the bullet and moved everything and getting the benefits along the way as they were coming out. But since that time, a lot of the services, a lot of the offerings have changed. The cloud has really become this very large entity out there, and not everyone really can understand or navigate it well. So you almost really need like a cloud map, or honestly like a cloud atlas. Okay, that's a really bad joke. I can hear the boos from here. But whether you're large, whether you're small, you made the decision to move to the cloud. So there's 5 things you really need to kind of focus on. Measuring your existing capacity is very important. Start small, read everything. Remember, you're still part of a team. That's a very important one. And ultimately, be a master of your own recoverability option. Okay, so we're just going to go through some of these in a little more detail here. So, gathering server metrics. Something that DBAs. I'm speaking as a DBA. Something DBAs are very good at, right? But not every server has a baseline necessarily in your organization. You may have software that provides that baseline for you, but you may have it limited to a certain number of servers. But once you decide on which servers you're going to be moving to the cloud, you obviously want to get a good baseline because that's going to be important when you move or decide to move, right? So the idea of a lift and shift, you're going to take your entire infrastructure, your on-premises infrastructure, and you're going to move it into the cloud. That's not really necessarily a feasible way to move to the cloud. You want to, before you do, certainly understand the cloud tiering structures. You want to understand the services that are available to you when you decide to move to the cloud. And you actually want to do some work up front, obviously, besides just a baseline. Maybe you're looking at taking some physical service, for example, and moving into a virtual space. And you can do that in your own organization prior to moving that to the cloud. So you're getting a feel for not just going from physical to virtual, but then now staying with virtual as you move to the cloud. You may also notice that in several organizations, there's a tendency to over-provision, right? So if you have servers that just have been provisioned, for 5-10 years out, and really just to make sure that there's enough space, enough RAM, enough IOPS, and sometimes that's done to overcome some design flaws as well. You may take the time to actually redesign the application that you're moving to the cloud, and at the same time, pare down what you're going to be using when you get to the cloud. I'm going too fast on these slides here, apologies. Okay, so the idea to start small, that's another tip. You may, when you decide which cloud provider you're going to be using, want to start off with a very small environment, kind of a low-risk environment. Allows everyone on the team to become familiar with the new cloud environment, learn the billing rates, learn how to integrate all the processes, and really to be done at a lower risk. Now, you've seen some of the different names of these environments as dev, test, staging, pre-production. My favorite is pseudo-production, where you're going to take an application and move it to a new server that you might have built up. Maybe it's a clustering solution, or maybe you're taking advantage of always-on availability group, but that becomes a pseudo-production environment, and that can be moved up to the cloud as well. But really just think of the idea of you want to use something that's going to be low risk, easy, small footprint, just to become familiar with the different services before you make the move with main production mission critical applications. Okay. Okay, obviously important to read everything. I'm not going to do the typical acronym there, but there was a lot of fine print, and understanding that there's going to be someone in your company who's going to need to understand everything about the different service offerings, billing rates, cycles when you decide to move to the cloud. Who's going to be responsible for things like security breaches or data corruption, or if service is actually unavailable for a period of time, right? Then that does happen. So just because you're moving to the cloud and you're expecting a certain level of risk with that, knowing that you're kind of offloading some responsibility there, there are things that you're still responsible for as well. So make sure you just read all of the available documentation as you move to the cloud. And it's obviously important to know that you're, well, for me, going too fast on these slides. Sorry.
Yeah.
Thank you, Tony. You're still part of a team. When I was having a conversation with my boss, I was a DBA, but I knew we had server admins and network admins, and there are things that I may have worked with in the past but may not be as familiar with. For example, DNS, VPN tunnels, VLAN technology. These are all things that network administrator is going to do, and they're still going to be required to do that if you're talking about moving your infrastructure as a service, your VMs into the cloud, doing CIDR blocks, things like that. That's not something a DBA is typically going to do. The whole idea of administering cloud services and cloud offerings is that you're still going to be able to use the team members you have. They just may take on a kind of conglomerated role. You might see network admins and sysadmins moving into more of a cloud administrator type of role, but someone's still going to be there to manage everything, and you're not going to be kind of left floundering alone as a DBA out there. You're still going to be working with a team who needs to understand the environment just as they do on premises. Okay, thanks. And finally, being a master of your own recoverability option. Business continuity, obviously very important. I'm speaking primarily in this case of IaaS when you're moving to the cloud, your infrastructure. But there are other offerings as well. Some of the terminology that you're familiar with is DBAs, always on, availability groups, database mirroring, log shipping, and backup and restore. But there are other things you may become familiar with, geo restore, geo replication, for example. But understanding that there are different scenarios, hybrid clouds, private clouds, public clouds, and if you're going to be using a hybrid scenario, in this case we're talking about taking a technology that you're familiar with, but then using that same technology to offload those services to a cloud VM, for example. So always on availability groups, it's a great feature. Doesn't require shared storage, but it is enterprise edition, right? So it's kind of costs a lot of people out in that case. Database mirroring is going to be deprecated. Log shipping definitely has high administration overhead and is certainly limited therein by a lot of inabilities to automatically fail over, for example, a lot of manual intervention. And backup and restore, obviously, if DBAs are doing backup and restore, that's not going to be a solution that's really going to move a lot of companies forward for high availability solutions. But in the case where you want to actually use standard edition of SQL Server, you want to have that failover cluster instance in Windows Server failover clustering, for example. How do you do that in the cloud, where a lot of cloud providers right now don't really offer shared storage solutions, or if they are, they're very expensive, and in a lot of cases some of the cloud providers are just not getting to the point of being able to offer that even as a service. So with that, this is where SIOS comes in. And this is where I'll introduce Tony again to talk about SIOS Data Keeper Cluster Edition. That will really answer some of those questions of cost and how to take advantage of using a failover cluster instance but without having to have shared storage.
Great, thanks a lot, Rodney, and hello everyone again. So I'm going to be talking about a way that you can deploy true failover cluster instances of SQL up in the cloud, where either A, perhaps you want to do this with standard edition in a 2-node configuration. You basically want to do that without making the jump to enterprise edition and without having to rely on some type of shared storage up in the cloud, which can either be, as Rodney mentioned, costly. It can be complicated to get that set up. If the cloud provider even provides that as an option, and also, if they do, what I've seen is there's generally performance limitations for that as well. So we'll get into those details here. Now, of course, the cloud providers, they have a certain level of uptime that they provide you for their their regions or their availability zones or fault domains, whatever the term for the particular cloud provider is. But the reality is there are still outages. So you need to make sure that at the application level, in this case at the SQL level, that you still have a reliable HA strategy, so that you can you're not relying on what's happening underneath the covers in the shared infrastructure. You want to make sure that that doesn't affect you and that doesn't take you down. So if I move along here, for anybody who's set up a cluster in the past, a lot of this is going to be a lot of familiar concepts here. But if I asked you to draw a cluster up on a whiteboard, this is what most people would draw: a couple of servers with some type of shared storage. But in this type of a clustering architecture, shared storage generally, if you're talking, on premises with physical servers and a SAN, you've got redundant disks and controllers and things like that. But still, the shared disk is technically a single point of failure. So you've got cost, you've got complexity, and then also, you've got a potential single point of failure with the shared storage. And if the storage has an issue, it can take out the entire cluster. Now, if you wanted to set up your own type of shared storage in the cloud, maybe you fire up an iSCSI target on a virtual machine up there. What you're doing in that case is you're really just moving the failure point from the SQL Server down to the iSCSI target, unless you somehow make that highly available as well. So, that's an approach that I usually don't recommend here. So, this shared disk is a requirement of Windows Server failover clustering in general, whether that's for a SQL cluster or you want to make a highly available file share or a custom service or application. It just requires shared storage. Now, what SIOS provides is we have a solution called Data Keeper, specifically Data Keeper Cluster Edition, or DKCE for short. And what Data Keeper Cluster Edition does is it essentially eliminates the shared disk requirement from a Windows cluster. So now you can deploy a true SQL failover cluster instance, or FCI, or any other clusterable service or application and eliminate that shared disk. And DataKeeper does that by providing real-time, continuous, block-level data replication between your systems. And basically, we're replicating at the Windows volume level. And I'll show you a demo a little bit later on how this works, but it's quite easy to set up. So think of DataKeeper really as a software RAID 1 mirror going across the network. You know, in this diagram here, I've got a 2-node cluster. Each node in the cluster has its own, independent storage. And DataKeeper is replicating the Windows volumes here block for block, so you have an identical replica between systems. So, if and when your SQL Server fails to it tells the direction of the mirror to switch. So again, you're getting full instance level protection. Rodney mentioned, you've got other options such as mirroring or log shipping or even availability groups to Enterprise Edition. I get asked. Probably the number one question that I get asked is, well, how is this different from availability groups? And I've got a slide coming up that goes into some pretty good detail on how they differ here. Both offer a similar architecture. You've got no shared disk, but with availability groups, you're doing basically database level replication, whereas with DataKeeper, we're doing volume replication, so you can protect really any clusterable service or application. So what this allows you to do is you can now fail over your SQL instance between availability zones, or in the Azure space you'd have different VMs and different, they call fault domains. You can do this within a region. You can even do this across different regions. You can even cluster on premises or a hybrid. You might have some cluster nodes in your data center and a failover cluster node up in the cloud. So this solution is server and storage agnostic. Basically, you just need to make sure that your drive letters and sizes match. Then you also want to make sure that you've got sufficient bandwidth between the source and target sides of the mirror, because we want to certainly replicate that data as fast as it gets written to the active cluster node, for maximum data protection. So, and this replication can be done either synchronously or asynchronously. You have that option when you create the mirror, and I'll show you what that looks like in a demo here. So again, the great thing about this is, you can either get local HA within a region. You can either, also this can be DR if you want to fail over, to a different data center or a different region here. And it all, piggybacks on Windows Server failover clustering. So for those of you who have set up a failover cluster for SQL Server or any other service or application in the past, you can reuse all those skills. You're not going to have to reinvent the wheel here. The way that the cluster works, that's all the same. DataKeeper is just providing essentially a replicated disk resource, similar to what the big SAN vendors are doing if you bought two identical SANs and turned on the SAN replication options and integrated that with failover clustering. We're doing that, but just as a simple software solution here. So you really get the flexibility and cost savings, here without having to, deal with SQL Enterprise or the cost or complexities of, or often limitations of the shared storage option in the cloud, if it even exists. So, I've got a couple of slides that show you what a typical cluster up in various cloud providers look like. Basically, it's going to be pretty much the same slide. So here's a diagram up in Amazon. And what you want to be mindful of is you want to put your cluster nodes in different availability zones. You want to do that because if an AZ goes down, you don't want it to take out your entire cluster. So this is a typical deployment architecture. We've got 3 systems here. I've got two cluster nodes called SQL 1, and so we've got a typo here. It's to be SQL 2 on the right, the one in availability zone 2. So I've got my 2-node SQL cluster. And again, if I'm doing only a 2-node cluster, I can do this with SQL Standard Edition and save a lot of money here on SQL licensing. And in a traditional shared disk cluster, you would have a quorum disk or a disk witness, as it's now called. Well, when you're dealing with a configuration where there's no shared storage, we'll call it a shared nothing cluster, also known as a SANless cluster. You can't use a quorum disk or a disk witness. So in that case, you would use the file share witness option that Windows Server failover cluster provides. So in a perfect world, you'd be deploying this in a region that has 3 availability zones so that you don't lose multiple components all at once. So ideally, you have your 2 different cluster nodes and 2 different AZs, and have a file share witness in a 3rd AZ if possible. And that's what a typical cluster up in Amazon looks like. Now, next slide here, I'm going to show you what a cluster up in Azure looks like. And you'll notice it pretty much looks the exact same thing. Looks like the exact same configuration. The difference here is really with terminology. So in Amazon, they've got their availability zones. In Azure, you'd make sure that your Windows VMs up in the cloud are in different fault domains. So same idea. It's separated so that they, if there's a hardware failure or network failure, it's isolated to that fault domain or that availability zone here. So here again, got a 2-node configuration with a file share witness, and if SQL Server fails from SQL 1 to SQL 2, through the DataKeeper integration with the cluster, it automatically tells the disk replication, the DataKeeper replication, to switch directions automatically. So, once you set up the cluster, once you configure DataKeeper, which is a 3-step wizard, the way that you install SQL into the cluster, the way that you fail over SQL between cluster nodes, and the way that you live your day-to-day life in SQL Management Studio or what have you, none of that really changes. This just looks and feels and acts like your typical SQL cluster, just simply doesn't have any shared storage because DataKeeper is providing the real-time disk replication underneath the covers. SQL doesn't know that the data is being replicated. DataKeeper is a filter driver that sits right beneath NTFS. And when writes come down, we simply split the writes, and one copy goes, in this case, to SQL 1, and the second copy of the block goes to SQL 2, either synchronously or asynchronously, depending on how you want to set that up. So if you've got your cluster nodes within a given region, you generally are going to go with synchronous replication because you've got a high-speed, low latency. You've got local area network-like network conditions here. So synchronous replication is always preferred if the network will facilitate that, and that gives you maximum data protection. It's a double commit, so when any data is written to the active node, that it's safely on the any standby nodes in the cluster. Now, if you're doing this with between regions or from your data center up to the cloud, and you're going across the internet, and perhaps there's a significant amount of latency, that's where you might want to go with asynchronous replication. But that's, oftentimes that's, the classic, performance versus potential data loss, question, and it comes down to your business's recovery time and recovery point objectives, and you can select which mode of replication makes the most sense for your business requirements here. So all 3 of those slides really pretty much look the same, just have different terms based on the different environment that you're in. But we're looking at most common configuration of a 2-node cluster with a file share witness. That's typically how this is deployed up in the cloud. Certainly, you're not limited to that. You can have more nodes in your cluster. You can have you can architect that based on the resources that you want to leverage and the other business requirements that you have in place here. So back to the question before and the slide before that Rodney went through, where he's talking about the different options like database mirroring and log shipping and availability groups and just backup and restore. So most commonly we get asked how this differs from availability groups, and currently availability groups is an Enterprise Edition only feature. With SQL 2016, yes, some of this will be available in Standard Edition, but it's going to be limited. So you can set up a 2-node SQL Failover cluster instance with Standard Edition. So if we look at the way that this slide is laid out, on the left, that's always on availability groups. The center column is an always-on failover cluster, or FCI. That's your typical shared storage cluster. And then on the right-hand column, we have a SQL Failover cluster instance, but this time with DataKeeper doing no shared disk and disk replication here. So it's the best of both worlds. It gives you the ability to eliminate the shared disk from your configuration, but it also gives you full instance level protection and failover like you have with a traditional cluster. So again, it works with the Standard Edition here. That's a very compelling point here for a lot of customers. Also, currently, availability groups doesn't support distributed transactions. If you rely on MSDTC, you're not going to be able to use availability groups. Now that will be changing in SQL 2016 here, if you're on Windows Server 2016, is my understanding. Availability groups also has upper limits on the number of databases per AG and AGs per instance, whereas a SQL FCI with or without DataKeeper, your only limitation is basically the resource in the box. Your upper limit is the upper limit of what SQL Server can support itself here. Also, with availability groups, it's just replicating and failing over certain user-defined databases that you specify. So things like the master MSDB, your SQL logons, your SQL agent jobs. With availability groups, those aren't protected. You essentially are dealing with two standalone instances of SQL doing glorified database mirroring, and you have to manage them as two different SQL servers. Whereas with a SQL failover cluster instance, it is one clustered instance of SQL. Whatever change you make, automatically fails over. So the entire SQL instance is protected and failed over. So this lowers the administrative overhead. This also eases database administration because you're dealing with half the number of SQL instances running out there in your environment. So especially as you move to the cloud, it's really easy to just provision new systems. Okay, hey, I need a new SQL Server. Click a few buttons, and you've got some new VMs with SQL Server running. So keeping control of all that and minimizing the number of resources you have to manage, both from a management perspective, but also a cost perspective, because you're going to be paying per hour for each new VM that you fire up. So that's an important aspect here. Now, also, oftentimes, you've got a mission-critical application, and the data associated with that application might live outside the database. There's database or data or information that lives inside SQL Server, but there could be external data as well. Maybe there are some PDF files or flat files or something else that lives on the file system outside of SQL Server, but it's still important to the application. So you want to make sure that that gets protected as well. That can certainly be done with DataKeeper, again, because DataKeeper is disk-level replication. So you tell it which drive letters you want to protect, and whatever data happens to live in that drive letter is going to be replicated and failed over. So you just say, hey, I want to replicate the D drive, and the E drive and the F drive. So maybe those 3 drive letters, and perhaps your SQL databases live in 1 drive letter, your SQL logs live in a second one, and maybe your custom application data lives in the 3rd. Or you can put them all in one. It kind of depends on how you want to carve up your drive letters here. Also, performance is a big difference. We've done a lot of head-to-head comparisons, and our block-level replication with synchronous mode has a lot less replication overhead than availability groups here. So it's not going to slow down your system if you go synchronous as much as availability groups will. So those are some of the key differences currently here between a failover cluster instance of SQL with DataKeeper versus availability groups. So I just want to make sure we kind of went through that in some detail. And now what I'm going to do is I'm going to switch gears, and I'm going to bring up a demo environment, and we'll show you how this actually works. So here what I've got is what looks like a standard run-of-the-mill 2-node failover cluster. I've got 2 servers in the cluster configuration. They're called SIOS 1 and SIOS 2. And for those of you who have set up a cluster in the past, you're going to notice two differences. The first is with my witness. Again, because there's no shared storage. I don't have any shared disk up here in the cloud, so I am using a file share witness. And in my environment, I simply have three systems. I've got cluster node 1, so SIOS 1, I've got SIOS 2, and then I have a 3rd server, which is my domain controller. And because I don't want to provision extra servers here in this example, I put the file share witness on my domain controller. So it can be as simple as that, or you could put it on dedicated system. It's really up to you. So first difference from a traditional shared disk cluster is here I have a file share witness. And actually with Windows Server 2012 R2, Microsoft recommends that you always configure a witness, whether that's a disk witness or a file share witness based on your configuration, because 2012 R2 has 2012 introduced the dynamic quorum feature, and 2012 R2 introduced the dynamic witness feature. So the cluster is smart enough to know whether or not the witness should have a vote or not based on the number of nodes in the cluster that are online at any given time. So always define a witness, whether it's a disk witness or a file share witness. So that's one difference in my configuration compared to a standard shared disk cluster config here. The second difference is with storage. So here, if you look at the cluster disks that I have, I've got a handful of these data keeper volume resources. So get data keeper volume K, P, Q, and S. I'll create a new one of these in just a couple of minutes. But in your traditional shared disk cluster, you've got what Microsoft calls a physical disk resource, aka a shared LUN on your SAN as an example. And you would see cluster disk, X, Y, Z. Again, in this particular case, we don't have any shared storage. So this is really where Data Keeper comes into play, and we're making local storage that we replicate and keep synchronized in real time. We're making that look and feel and act as if it were shared storage to the cluster. So here I've got a couple of different resources. Data Keeper Volume K is assigned to my file server role. Data Keeper Volume S is assigned to my SQL Server role. Then I've got these two others that are sitting in the available storage pool. So that's the second difference, is you've got Data Keeper replicated volume resources instead of shared physical disk resources. Now if I go to the cluster roles, I actually have a SQL Server Failover cluster instance in the cluster, but also just to show you that this can work for any other clusterable service or app, I also have an HA file share that I could fail back and forth as well. So my SQL Server is running on SIOS 1 and my file server is running on SIOS 2. So I have an active cluster, if you will, at this point, where I've got SQL on one node and the file share on the other. They're each basically a failover for the other one. You've got a lot of different options there, a lot of flexibility. Again, the kind of the behavior and the the bells and whistles and the rules of a typical on-premise shared disk cluster, that all applies. That all still applies here. We just are getting rid of the shared disk. So if I look at my clustered instance of SQL Server, down here at the bottom, this should all look out of the box. I've got a network name and a virtual IP, and then I've got my SQL resources here, my SQL Server, my agent. Here's the difference. So the storage resource for SQL Server is this Data Keeper Volume S. And this Data Keeper Volume S looks and feels and acts like shared disk, but in reality, I have an equally sized S volume on my two cluster nodes, SIOS 1 and SIOS 2. And Data Keeper is replicating that, in this case synchronously, so that I've got a block-for-block copy of my data between these two systems. So if and when I fail over, and I'll show you that in a little while, all the data is protected. It's on the other node waiting to take over when the other cluster node comes online. So going back to the cluster disks here, I've got 4 in there right now. Let me just show you what it takes to create a new one. It's very simple. So I'm going to pull up the Data Keeper UI, which is just a simple MMC snap-in. I'm looking at an overview screen where I can see the different servers, I can see all their different drive letters, and which ones are replicated, if any. So here I've got, you can see here, this coincides with what we saw in Failover Cluster Manager. I've got those 4 existing mirrors. I have an extra drive letter right here called R. I'm going to create a new mirror to protect that and add that to the cluster. So let's do that right now. I'm going to click Create Job and just give it a name. Very creative here, R drive, and click Next. Now I'm going to go through a 3-step wizard where I pick my source, my target, and finally my mirror options here. So I'm going to go in here, and if you have multiple NICs, depending on the cloud provider, some you can do multiple NICs, others it's more of a challenge. So if you can, that's always a good idea. You can separate your replication traffic from your client access point, your traffic. So I have this 10-10-10 network that I use for replication. I'm going to select R and click Next. Step 2, I select my target. There's nothing to change here. It picked the other machine, picked the IP on the that network, and it picked the same drive letter. And click Next. Finally, I can select my mirror options. I'm going to put this into synchronous mode because these are in the same region. So I've got a high-speed, low latency network connection between them. So that's appropriate for synchronous replication. And click Done. So that's it. Simple three-step wizard. It's going to create this new mirror to replicate the contents of R from SIOS 1 to SIOS 2. And it just popped up on my screen. It's now asking if I want to register this with Failover Cluster Manager. And before I click yes, let's just revisit the cluster. If you recall, I had 4 DataKeeper resources in there right now. Once I go back into the DataKeeper UI and I click yes, it registers that with the cluster. And now if I go back to the cluster, I've got this brand new DataKeeper volume R, so this 5th DataKeeper resource in the cluster. It's sitting right there in the available storage pool, and I can use this like any other cluster disk. So let's go back to my clustered instance of SQL Server, and maybe I want to add storage. I want to start putting some new databases on this new drive letter. I just add it to the role, and now they'll all fail over together. So let me show you a failover quickly here. So I've got SQL Server. It's running on node 1. Let's just go ahead and move this to the other node in the cluster. And this is all going to look like a normal cluster failover. But here it's also failing over the DataKeeper resources, which is telling DataKeeper to switch the direction of data replication automatically. So again, there's, kind of set it and forget it. Once you create that mirror, you just live your life in Failover Cluster Manager or SQL Server Management Studio like you have in the past here. So that's really all there is to it. Again, here I've got, kind of the best of both worlds here. I've can form a 2-node cluster, 2-node SQL cluster with standard edition. I've eliminated the cost and complexity of shared storage, if shared storage is even available for your particular cloud provider. And I've got, the full instance level protection. So it's a win-win here. So, again, let me just fail this back. And with that, I'm going to go back and bring the slides. That pretty much covers the content here. So just want to thank Rodney for going through those tips and lots of great information on things to consider as you decide to move to the cloud. And then certainly one important aspect of that is your high availability strategy as you move up there. So hopefully you'll consider DataKeeper Cluster Edition for that. And if you want more information, we've got some URLs here up on the screen. Contact via website or email or Twitter handles are up there as well. And I guess at that point, Greg, I'll turn things back over to you to see if there's any questions that we can answer.
Yep, great. Thanks, Tony, and thanks, Rodney. Yep, there's some questions. If anybody else has questions, feel free to type them into the question area, and we'll just answer as many questions as we have. We still have about 20 minutes, so we definitely have some time for questions. So, Tony, the first question for you is related to the multi-site cluster, SANless cluster that you showed on the Amazon screen, having multiple sites.
Okay.
And the question was, in that scenario, can users access data in zone 1 and zone 2 and zone 3? There's a third server in that cluster. Can you kind of talk to that?
Sure thing. Sure thing. So the way that the cluster works up in the cloud is the same as if you were doing this on site. So with a failover cluster instance of SQL, it's only running on one side of the cluster at any given time. So the SQL instance would only be on one of the nodes, and if there was a failure of that node, then it would fail over the instance and run it on a different node in the cluster. So it's not doing any type of load balancing or running the same databases on all 2 or 3 at the same time. So it's at the cluster level. I've mentioned you can do active-active. Really a better term for that would be like a multi-instance SQL cluster. We could have one instance on node 1 and a different instance on node B or on node 2. But at the resource level, it's only running on one node in the cluster. Now with DataKeeper, there is a target snapshot feature. So if you want to access the data on a standby node, you can take a snapshot and access point-in-time data on that, and then maybe fire up a secondary instance of SQL on that and attach the databases. So you could do that for things like periodic activities, like maybe nightly reporting or nightly backups, things like that. But for real-time queries and things throughout the day, the SQL instance is only running on one node of the cluster at any given time.
Okay, great. Rodney, this next question is for you, and it's related to selecting either Amazon or Azure or some other hosting company. And the person just was wondering, what kind of recommendations do you make for some of your customers when you're working with them, getting to the cloud? How do people decide kind of which direction to go?
Right, so it is challenging for sure. And I work with, several different cloud providers. In fact, hosting our parent company at Entirety is also a cloud provider. And this idea of a unified cloud experience. So there are services out there that will help you manage your infrastructure, whether it be in one cloud, two clouds, or multiple clouds, right? So the idea of the cloud, when you start breaking it apart, it's really the ability to communicate within and through clouds. It's difficult, right? It's difficult to decide which ones you want to use. I can't really recommend one over the other, but I can tell you there are services out there that will help you make that decision and actually help you manage that decision once you've made it.
Okay. The next question, again, I think is for you, Rodney, as well. And the question is, this DBA is actually being pushed to move things to the cloud. I guess there's been a decision to move that way. So just want to know what kind of things should they be sort of looking out for, and what are the gotchas that they really need to pay attention to?
Yeah, it goes back to the team, right? So I don't know the scenario, but if as a DBA you're being asked to move things to the cloud, if we're talking about moving a SQL instance, right, that's very easy to do. And one thing that I failed to mention previously is, there are a lot of free services that you can grab as well, whether it be Amazon, whether it be Azure. They offer free levels of participation. So if you have MSDN, for example, you can go out and actually use Azure Cloud, spin up VMs, set up SQL databases in those services, and get a familiarity with it without having to spend any money. But going back to your question, if there is a specific scenario where you're moving a specific database or a specific server instance, again, I need to know a little more about the background, but you'll want to definitely go and take advantage of those free services available to you and get familiar with it yourself. And then if you have other questions that are a little more complicated, then you can answer as a DBA, like I was talking about, network administration, storage administration, and that's where you can get other team members involved and help you answer those questions.
Okay, great. This next question for you, Rodney, as well, and it's related to the slide you talked about resources and reading as much as you can. And they're just wondering, are there any things that you can recommend or kind of directions to point people to get as familiar with the cloud environment as possible before they actually move there?
Yes, excellent. So if you're, and I'll use Azure as an example again. So if you're going to get Azure and you're going to the portal, in my case, I do have that MSDN subscription. I can see kind of my credit status as I go along. It's a little drop down that's in the portal. I can select that, and it'll take me to essentially a detailed view of my charges. It has a nice graph that shows what my processing utilization has been for that billing cycle. It shows a lot of information. There's links to other information from there as well. Now, one thing that might be a gotcha in that regard is data in and data out. You can have your information stored in the cloud, but if you start pulling that information out of the cloud back into your on-premises application, for example, right, that is going to be a charge of its own. And as you are preparing to set that up, for example, let's say you're going to initiate that connection into the cloud. There'll actually be information that will pop up telling you, hey, you're about to set this up. You might want to go read this document here that's going to tell you all about how much it's going to cost to pull that information out, right? So it's all there available to you. It's typically very friendly and in your face, letting you know exactly what to expect in a lot of cases. But also each of these services, you can go directly to the licensing page and it'll break down everything for you. Very easy.
Okay. Tony, this question is for you, and it's related to the size of the environment with setting up the SIOS product. Is there any limitations to how large the database can be, or how many databases that can be replicated in the cloud?
No. Your limitations really, with SQL Server, how many, the amount of resources you assign to SQL Server and all of that. So with DataKeeper, depending on how you carve up the disk, each mirror needs to have a drive letter. So your only limitation is 20-something drive letters. That's about it. Probably the most important thing to consider from a sizing perspective is, it's not so much sizing, but it's understanding your data's rate of change, because you want to make sure you've got enough bandwidth between the different cluster nodes so that the data can be replicated in real time. The best way to do that is is just pull up perfmon and look at the logical disk write bytes per second for the drive letters where your SQL databases and logs, or all that kind of stuff lives, and look at that for some representative time period, and that'll tell you how much bandwidth you're going to need to support real-time replication. So rate of change versus bandwidth is probably the most important thing to consider when you're looking at a shared nothing configuration.
Okay, Tony, another question for you is related to a hybrid model, and they're just wondering, is it possible to have an on-premise server and replicate data back and forth to the cloud?
Yeah, most definitely, most definitely. As long as you've got, again, this kind of goes back to rate of change versus bandwidth, as long as you've got the appropriate network connection between your site and the cloud, and the different cloud providers have different options to get direct connection to the cloud, or maybe just set up a VPN tunnel from your site to the other site. So, assuming you've got the network connection in place, then yeah, you can most certainly do that. DataKeeper is server and storage agnostic, so a couple things. Just want to make sure that A, the drive letters and sizes match, and then B, when you form your cluster and it goes through all those cluster validation tests, just make sure nothing fails. A lot of the storage tests will come back with warnings because it's basically looking for shared disk and there isn't any. That's perfectly fine. That's considered a fully supported cluster as far as Microsoft is concerned. You just can't have any failures. Basically, no red X's in the validation report, and you're good to go. So, but again, as long as drive letters and sizes match, you've got sufficient bandwidth and network connection between the sites, yeah, you can most definitely do kind of a hybrid config where you've got one cluster node on site and a different cluster node in the cloud, or things like that.
Okay.
Hey, Greg.
Yes.
Greg, can I ask just go back to the previous question. I just wanted to relate it to more information. If you just go to Bing, I'm saying Bing because I'm Microsoft MVP, but you can go to Bing or Google and just look up Azure Licensing FAQ, and it will take you directly to the virtual licensing FAQ link, and in there it has great information on how to license your Azure VMs for SQL Server and everything else. An important note there too, I might have mentioned, is that you can actually bring your own license, or you can get the license for different editions of Windows and SQL Server in the cloud itself. So thanks.
Okay, the next question, Rodney, this is for you as well, and they're just wondering, what are some of the cons for not moving to the cloud? Do you have any things, recommendations where you would tell somebody, don't make the move to the cloud?
Sure, absolutely. I worked in a very large insurance company, right? We dealt with lots of data, right? So on top of dealing with lots of data, you have a lot of processes surrounding that data, and it gets very complex. So organizations who have a very complex infrastructure, who've already invested, just millions of dollars sometimes in various different data centers, you're not going to move that application very easily. And on top of that, you're going to have situations where you have security constraints, whether it be financial or HIPAA or SOX compliancy. The data really has to be secure. You have to manage it, and it's going to be kind of complex to do that kind of lift and shift, right? In those cases, it may not be the best solution for you to get to the cloud, or maybe you're waiting for a specific event to happen, like a certification for the security requirements for a particular application, right? And when that comes along, I know, again, hosting my company has those certifications. So when that comes along, you might look at, okay, well, now it's time to move that application. Again, thinking about how can I maybe possibly downsize, make this very complex and large data set a little more easily to manage. If that's possible, then yeah, maybe it's a good fit. If not, it might just be too costly to even move to the cloud.
Okay. Tony, this next question is for you, and it's just related to setting up your storage and the page sizes. Are there any limitations using DiskKeeper? So the specific thing is that wonder if you can do 64K page sizes when you set up your storage.
Yeah, you can do all that. The key is just make sure that everything matches on the different sides of the mirror. So, but yeah, that's no problem at all.
Okay. The next question, either for either one of you guys, is related to the minimum version of SQL Server that can be used to move database to the cloud. Do you know what either Amazon or Azure supports as far as what version of SQL on the low end?
Yeah, I think if you're talking, it really depends on if you're talking about installing SQL yourself. You're going to manage it as a company internally, an infrastructure as a service example, versus a specific data software solution like Azure has the SQL databases and Amazon has RDS, for example, right? So those services are updated frequently, and the latest version of SQL Server is deployed frequently as well. If you're going to be installing SQL Server in your own VM in the cloud, I think you're limited to whatever version you can, that you have available on media to install.
Okay.
Yeah, and then the only other thing I'd add to that is from HA perspective, things like, if you are putting cluster nodes in Amazon as an example, and they're in different availability zones, that means they're in different subnets, and older versions of SQL Server don't support cross-subnet failover. So there's a couple of little gotchas on some older versions. If you really need to go down that route, contact SIOS, and we can talk about different ways to address that. But in Azure, it's not really an issue because the different nodes in a data center in different fault domains, it's all in the same subnet. So there can be little gotchas depending on the version and the cloud provider. But SIOS can help you work through all that if you're really looking to deploy an older version of SQL Server.
Yeah, I would recommend anything like SQL Server 7 or 2000. I'd avoid those.
Okay. All right, Rodney, next question is for you. As far as performance goes, I guess the thought out there is you move to the cloud, performance stinks. So can you just kind of talk about performance a little bit and also kind of some of the benefits you get by moving to the cloud?
Sure. Right, I mean, performance is not going to be what you may expect in all cases, right? It's really, again, goes back to what I was talking about when you go from a physical to a virtual, right? So you have a certain level of anticipation there, right? But you anticipate that this is going to run at least above average to the point it's not going to degrade the performance of your application, right? So it's really all about setting the expectations based off the baseline. If you have a virtual machine that has 8 gigs of RAM and has so much network bandwidth and can do certain IOPS, then the expectation is when I move to the cloud, it's going to have that same level, at least of workload, right? So the same level of performance based off the tier levels you purchase. You purchase 8 gigs of RAM, you're going to pay for the IOPS, right? Now, that additional increase in tier level, you're going to pay more for, but going into it with the knowledge of this is my expectation from the baseline I've done versus the baseline I expect. Now, when you start talking about these hybrid solutions where you have different network bandwidth requirements, right, for your application, sure, the applications are going to perform a little slower if you happen to be in the cloud and you don't have necessarily, kind of localized, high-speed bandwidth that you would in your internal organization. But in those cases, you might be looking to the cloud to kind of offload in case of a disaster recovery. So you have a certain level of understanding that this is going to be a temporary situation potentially for disaster recovery. Right? It really depends on what you're using the cloud for, whether it be HADR, whether it be to offload some applications. One of the points I didn't really make earlier, and I apologize for that, is when you do take the time to decide I'm going to move this particular piece of my infrastructure or application to the cloud, many companies also take advantage of that time and decision to retune, rebuild, reformat their applications to take more advantage of the cloud services being offered. For example, there's an expectation in a lot of companies that I can just scale out my SQL Server infrastructure as opposed to scaling up, which has been the typical kind of out of the box or standalone kind of way to scale SQL Server. Well, with some of the new services in various different cloud environments, you have the idea of elastic services, and you can throw a database anywhere and it's going to automatically scale out or scale down based off the requirements of the software, right, and the usage at the time. Well, you have to design your application for that. So if you want to invest the time and enhance your application to the point where you have expected returns and even increased returns based off of the offerings, you're going to spend the time to redesign your application as well.
All right, Tony, the next question is for you related to setting up the replication between two different nodes. And just wondering, is there downtime that it's required to do that, or can you begin using one and then SIOS Data Keeper just kind of replicates data behind the scenes? Can you just kind of talk to that quickly?
Sure. So when you create the mirror, as you saw in the demo earlier today, I created the mirror to replicate that R drive. Nothing had to come down. The only time that you're going to have to reboot a system is when you first install DataKeeper. You run the setup.exe on the different nodes, and you do have to reboot so that DataKeeper's filter driver can activate. But once you've done that, to configure it, to create the mirrors like we saw here today, no, the drive's not going to be locked or nothing has to go offline. You don't have to reboot to do that, anything like that. Just the initial install.
Okay, great, thanks. Let's see, the next question, Rodney, is related to, is there a way to test moving to the cloud, again, either using Amazon or Azure, without the need to spend a ton of money to get things set up? Do they offer any kind of, how does do you know how the whole pricing works for that, or can you talk to that at all?
As far as the billing for setting up kind of that test environment, I'm sure Microsoft will be willing to work with you. It's really kind of an a la carte kind of solution for a lot of cloud services. You know, you pick your tier level, you spin up your VM, you install your software, you know, and that can be done kind of following the bouncing ball, right? But if you're looking to say, I want to take a particular server and I want to spin it up there and I want to use it for a month or whatever, but I don't necessarily want to pay for that. I just want to see how it's going to perform, right? Yeah, going back to what I was saying about having an MSDN subscription, if you have that, you can certainly do it. Any other free ways to do it, I don't really know. I'd actually have to defer that to a Microsoft sales engineer or person to see if they offer that as a solution, as kind of a free test service.
Okay, all right, great. All right, Tony, here's a question that just came in that's related to, again, using DataKeeper, and just wondering, I guess you've pretty much been talking about the cloud today, but somebody just wondering, can they use that solution just locally if they don't have shared storage?
Oh, most definitely. Yeah, this doesn't have to just be done up in the cloud. That was just, really the kind of the topic of our discussion here today. DataKeeper is server and storage agnostic, so you can use this and configure, quote unquote shared nothing clusters in your data center using physical servers, using virtual machines, really with any hypervisor, or even some mix. So you can most certainly do this outside of the cloud as well.
All right, then another question, just as follow-up to a previous question that you answered, related to the drive letters and setting those up similar on the machines. And just somebody asked the question, is it possible to use, they said manage paths, I guess, or mount points for that, or does it have to be just one logical drive, letter by letter?
Currently, drive letters are a requirement, yeah, not mount points.
Okay. All right, let me see what else we have. All right, there's another question, Rodney, for you. Again, just moving to the cloud, and they're just wondering, do you have any recommendations as kind of what to move to begin with? Is it small applications, standalone applications? Do you have any thoughts on kind of customers that you've helped move to the cloud, what you recommend moving instead of, like you mentioned before, that you don't want to move that huge healthcare application? But do you have any recommendations on kind of what is a good step to start with?
Absolutely. I highly recommend taking your development environment. Most organizations who are developing internal applications have, a fairly extensive development / QA / test environment, and that's all, spun up in virtual machines that are, in data centers, and that is a great first environment. Like I said, it's kind of lower risk than production applications, and it allows the team members to get familiar with that environment. But I was going to say something else about that, I forgot, but having the ability, I know what it is. So when you have this dev environment, right, so it may not be typically used 24/7, but understanding that you're getting billed for by the processing and the cycle. So any uptime storage requirements that are for that dev test environment, you can automate the deallocation of those virtual machines. So if you know that they're not going to be utilized over the weekend or after hours, you can deallocate them. You can bring them back up, and you won't get charged for that downtime, right? So it's just a matter of, okay, it's going to take 5 minutes to bring up that environment, but I'm going to deallocate it as well. So just to summarize, test environments first and kind of build an automated solution either with Azure PowerShell or some of the scripting language to deallocate those machines when they're not in use.
Fantastic. Well, we're out of time, so I want to thank Rodney and Tony, and also thank SIOS Technology for sponsoring today's event. So please visit SIOS at us.sios.com to learn more about their SQL Server HA solutions. Also, please visit mssqltips.com to access all of our free SQL Server resources. As a reminder, this webcast was recorded, and you'll receive a follow-up email with the links to view the archive. Thank you for attending, and hope you have a great day.